Getting started in geometry, points, lines, and planes. The purpose of this section is to understand basic terms and postulates. Simply put, geometry is a branch of mathematics that studies the size, shape, and position of two-dimensional shapes and three-dimensional figures. In geometry, formal definitions are formed using other defined words or terms. There are, however, three words in geometry that are not formally defined. These words are point, line, and plane, and are referred to as the three undefined terms of geometry. However, they have an agreed upon description. A point names a location and has no size. It is represented by a dot, and it is identified by a capital letter, in this case P. A line is a straight path that has no thickness and extends forever. It is identified by a lowercase letter, like this L, or by 2 points on the line, like XY or YX. Please note that there is a line over the top of it, so it indicates it's a line. A plane is a flat surface that has no thickness and extends forever, kind of like a sheet of paper if it were non-stopping. It is identified by a script capital letter or 3 points on the plane that don't all line up in a single line. Refer to the diagram on the right to answer the questions below. What are two other ways to name CA? Well, you can name it AC. It should say AC, and you can name it FC. What are two other ways to name plane T? Well, you can identify it by three non-linear points, so they can be plane CE, BCE, or plane CDE. Notice BCE and CDE. What are the names of three collinear points? These 3 points are collinear, all on the same line, and those 3 points are collinear. What are the names of four coplanar points? Those are 4 points on the same plane. Those would be the ones that we use to describe plane T. So points B, C, D, and E. A segment or a line segment is the part of a line consisting of 2 points and all points between them. So it's identified by its endpoints, in this case AB. It can also be BA. Doesn't matter which direction you name it. An endpoint is a point at the end of a segment or the starting point of an array. So these C and D are endpoints, A and B are endpoints. Array is a part of a line that starts at an endpoint and extends forever in one direction. Notice this goes through S, so you would write it as RS. Note that this is going the other direction, but it's still written the same way, RS. It always originates with the endpoint and shows what point it passes through. Opposite rays are two rays that have a common endpoint and form a line. EF and EG both share E as the common endpoint, and they do create a straight line. So those are opposite rays. Refer to the diagram on the right to answer the questions below. What are the names of the segments? Well, segments are just the pieces here. So you have MN, you have NO, and you have OM. What are the names of the rays? Well, rays are a little different. They start here and go this direction. So you'd have MO, we have ON. Notice they're going in different directions. Then you have NO. Note MO and NO are not the same ray because they don't share this same piece right here. And then you have NM, which goes the other direction. Which one are the opposites? Well, NM and NO, because they both rays share N as an endpoint. A postulate or axiom is an accepted statement of fact. Postulates, like undefined terms, are agreed upon truths. Gives you some of the postulates below in algebra to graph an equation and find where two lines intersect. Postulates 1, 3, and 1, 4 are similar to the others, but in a three-dimensional space. So here we have that 2 points lie on exactly one line. Two distinct lines intersect at exactly 1 point. And then we go to a three-dimensional space. You have two distinct planes intersect in exactly one line. So there we've got the three-dimensional from here to there. And then there are 3 collinear points, there's exactly one plane. So 1, 4 and 1, 1 are similar, and 1, 2 and 1, 3 are similar. For the diagram to the right, to answer the questions below, name 2 lines that touch this figure. Well, we have line BF and we have line EH. So those 2 lines, but any one that crosses through an edge would work. Where do AB and BC intersect? Well, AB is here, BC is there. They clearly intersect at point B. What are 2 planes that intersect on BF? Well, there's BF, ABE or ABF or BEF, whichever way you want to name it, that plane intersects with BF, and BCG or BCF or FBG, whichever way you want to name that, also intersects at BF. Then we want to draw hatch marks through the plane that contains EHG, that's the bottom of the figure, and then shade the plane containing the points DCF. That is actually diagonal slicing through the figure. Okay, well, I hope this clarifies some of the information about points, lines, and planes.